Imagine you have a queue of agents that will maintain your GitHub repository by themselves. This will read issues, suggest fixes, and add labels automatically. So in this tutorial, we'll be building AI GitHub Maintainer that will read issue automatically, suggest solutions, add labels to that particular issue fully autonomous. We will be using CrewAI, FastAPI, and our local Ollama models. So let's understand the architecture of our product. So the main.py will be our entry file. Then we'll be having a GitHub webhook.py. This will listen to the webhook from the GitHub. As anyone creates an issue on that particular repository, this file will invoke our crew. Then in our crew, we have three agents: analyzer agent, solution agent, and labeler agent. Analyzer agent will analyze the issue and give the severity of the issue, the type of the issue, the component of the issue, and the summary of the issue. The solution agent will provide the basic solution how a developer can approach to that particular issue, and labeler agent will assign the labels like bug, good first issues, documentation, feature. Then we'll be having analyze task for the analyzer agent, solution task for the solution agent, and label task for the labeler agent. These agents will use the provided LLM. In this case, we will be using local LLM Quen 3 2 billion. After our crew complete the task, it will call the GitHub service, and that will push the comment and the labels via GitHub API. Now we'll see how to install Ollama in our machine. Now from the description, come to this link. This is Ollama. You need Ollama to run the local model. From this option, download the Ollama. It will start downloading the Ollama. It will ask whether you're using macOS, Linux, or Windows, and follow the step. Will be installed the Ollama. Then go to the models. In our case, I'll be using Quen 3 VL. In that, I'll be using Quen 3 VL 2 billion. On your machine specification, you can use any of these models. So to download the model, come to your terminal and hit Ollama pull model link. And it will start pulling the model, and it have pulled the model successfully. Then to check whether you have the model in your machine, hit Ollama list. You can see I have Quen 3 VL 2 billion in my Ollama list. Now we are good to go. Okay, so let's start the coding part. Open your favorite IDE. I'm using anti-gravity. Inside that, I've created a folder named AI GitHub Maintainer. So we will start by creating a Python environment. So to initialize the Python environment, I'm using UV. If you don't have UV in your machine, I'm giving steps to install UV in the description. So to create a Python virtual environment, you need UV venv. It will create a Python environment, and to activate it, we need to hit this command source.env/bin/activate. Now our virtual environment is activated. We'll start by creating a requirement.txt file. Inside this, we will be using CrewAI, Ollama, PyGitHub, FastAPI, UVCon, Python.env, and LiteLLM. We'll install the dependencies by doing uv pip install -r requirement.tsx. Our requirements are installed, so we can close the terminal. Now we will create a folder. We'll give them a name app. Inside that, we'll create a config file, config.py. In this file, we will be importing OS, and we'll load our environment. We will be taking GitHub token and repo name. We'll be giving our app name, and we'll do debug is equals to true for the development mode. Now we need to start by creating the services folder. So we'll create a services folder. Inside that, we'll create GitHub service.py. In this, we will be creating a class named GitHub service. Inside that, we'll be having few methods. The first method is to get the issue by the issue number. The second method is to comment on that particular issue by the issue number. Then the third method is to add label to that particular issue, and the fourth method is to get the issue data. Then we'll start building our agents. So we'll create a folder, name it agents. Inside that, first agent will be analyzer agent. We'll give it name analyzer.py. Inside this, we'll importing agent from CrewAI, and we'll return an agent by a role. We'll give it a goal, a backstory, verbose is equals to true. So we can see the logs of that particular agent. Allowed delegation is false. So this agent can't delegate its task to other agent, and we will be using our local model Quen 3 VL 2 billion. The next agent will be a solution agent. So we'll give a name solution.py. Here we are importing same agent. We are creating a method get solution agent and returning an agent. We'll give it a role. We'll give it a goal. We'll give it a backstory. Same verbose is equals to true, and allowed delegation is false, and we are using the same LLM model. Then our next agent will be labeler agent. So we'll give it name labeler.py. .py, and we'll be doing same. We'll be importing agent from CrewAI. We'll create a method get label agent, and we'll return an agent with a role, a goal, a backstory. Verbose is true, allowed delegation is false, and the same Ollama Qwen3 V1 2 billion model. After we finish building our agents, now we'll build task for that particular agent. So we'll create a folder named task. Inside this, we'll create a task for our analyzer agent. So we'll create analyze task.py. We'll be importing task from CrewAI and the agent that we have created. So here we'll create an instance of our agent and return the task with a description that analyze the following GitHub issue with the title and the body that will be passing as a prop, and return the issue type, severity, component, and short summary. Then we write what kind of output we need. So here I've written a structured analysis of the issue, and we are delegating analyzer agent to this particular task. Now the same thing we'll do for the solution task. So the same thing we'll do for the solution task. We'll give it name solution task.py. We'll be doing same. We'll be importing task from CrewAI and our solution agent, and then here we are creating an instance of our solution agent and returning the task with the description and what they need to provide, a possible cause, step-by-step fix, code suggestion, and file to modify. And then we'll be delegating the solution agent to this particular task. At last, we'll be creating a label task for our label agent. So we'll be doing the same. We'll be importing task from CrewAI and our get label agent method. Here we'll initialize our labeler and return the task with the description, and we'll ask it to give the appropriate label as bug, feature, enhancement, documentation, question, good first issue, help wanted, front end, or back end. So now we finish with our agents and tasks. It's time to create the queue. So on the root level of the app, we'll create crew.py. So in the queue, we'll be importing crew from CrewAI, all our tasks that we have created, and then we'll create a method run issue queue. We'll pass a title and the body in it. Then we'll create instances of our task by passing title and body to each task. Here we will be initializing our crew. We'll pass our available agents, our available task, and verbose equal to true to see the logs of the particular crew. And to start our crew, so we will do crew.kickoff, save the output in the results. And this is how we will be returning the output of each task. Analysis, in that analysis task.output.raw to format it clearly. Now that we have finished with our crew, we will create a webhooks folder. Inside this, we'll create a GitHub webhook.py file. This will be responsible to passing new issue to our agent, and then our agent will write a comment and add a label on that particular issue. So in this, we'll be importing an API router and request from FastAPI, run issue queue from our queue, and GitHub service that we have created earlier. Then we'll create the instances of a router and a GitHub. Then on this particular URL, we will be listening to that webhook. So now after the webhook comes, we will be checking the action of that webhook is either the open or a issue. Then we will be parsing the issue from that payload. After that, we will be parsing title, body, and issue number from that issue. We will send the title and the body in the run issue queue. This will kick off our queue. After that, we will save it in the results, and then we will parse in analysis, solution, and labels from the result. After this, we will populate the analysis and the solution in our formatted comment, and we will hit comment on the GitHub. After that, this is how we will add the labels on that particular issue. Finally, we will be creating our main entry file. So we'll give it name main.py. Inside that, we'll be importing Flask and our GitHub router. Then we'll be initializing our FastAPI server and an endpoint to check the health of the server. And then we'll be adding our .env file. In our .env, we need GitHub token. So to get the GitHub token, we'll go to GitHub. In the GitHub, go to settings. In settings, scroll down a bit. You'll see the developer setting option. In the developer setting, you'll create a personal token. Inside that, create a fine-grained token. I've created one token. I'll create it one again. So now we'll give a name to the token, AI GitHub Maintainer. We'll only select repository. Select your particular repository. Here I'm using LiveDocs repository that I have. You can choose whichever repository you want. We need to add the permissions, give the administrator permission, and make it read and write, and create a generate token. Hit generate token again. You'll see a GitHub token. You can paste it over here. Do not use my token. I'll be deleting anyway after the video upload. After that, we need a repo name. So to get the repo name, we'll go inside our created token. We'll find the repository name over here or the repository you have selected. Now, finally, we'll just create a Python file to run our server. So to run our server, I'll just create a run.py. Inside that, I'll put import uvcon. We will be running it on localhost and port 8000, and the reload will be true as if I make any changes in the code. Okay, so we are done with the coding part. Now we'll see it running. I'll open the terminal. To run our application, we need to do python run.py. It will create a server on our localhost 8080. But the GitHub Webhook can't access our localhost. So we need to create a tunnel through our localhost to any particular domain, and then we can access that GitHub's webhook. So to create a tunnel, we'll create a new terminal. In that, we'll type Cloudflare Tunnel hyphen URL, and we'll give our localhost 8000. This will create a tunnel for that particular localhost 8000. Now you can see we got a tunnel for our application. So now our application is temporarily serving on this URL. So by hitting this URL, we can check our application status is running. Come to that repository, go to the settings of that repository. Here you'll find the webhook tab. Open this and you'll see nothing over here. Go to add webhook. On this, paste that particular link given by the Cloudflare, and with that add /webhooks/GitHub. Then change the content type to application/JSON. Scroll bit, change this option. Let me select individual event. Scroll down, check issue comments, issue dependency, and issues. And then hit add webhook. You will see a webhook over here in your webhook tab. After that, you're all set. Now, to see it working, just go to issues. We'll create a new issue. We'll give it a title that the login button is not working, and we'll give a description. So I've created a random issue, and then we'll hit create. Just as our issue is created, we'll go to the console, and here you can check our crew is already started the work. We'll go to this response we get from our webhook, then our execution is started. This task is started. Analyze the following GitHub issue. Our analyze task is started. Then it is delegated to agent. So our GitHub issue analyzer agent is started. Then analyze agent gives this final answer. After that, our analyze task is completed. Then our solution task is started. It is delegated to our senior software engineer agent. Then this was the response from our solution agent. After that, our labeler task started. It assigns tasks to the labeler agent. Labeler agent finished it by giving a bug and a front end label. We will see in the GitHub issue that if our agent have added the comment or not. So here we can see our agent have added a comment just 1 minute ago that the issue type is bug, the severity is high, a component is front end, and the short summary is the login button is not functioning as expected, with the UI not changing after attempting to log in, including using Google OAuth. And this is the detail that our agent have provided. These are the recommended further actions. This is the possible cause, and this is the step-by-step fix. And also we can see our agent have added the labels and the front end. So now our repository maintenance can be automated by this agent. Your repo can now run itself. The codes are in the description. Subscribe for more AI builds. Thank you for watching.